All right, it's an honor to be here. Actually, I was quite used to sit here as a listener, not as a speaker. It's the first time for me as a speaker, as I've been actually studying here more than 10 years ago when I joined here. So it's a really honor. And back then, when I studied FitCTU, I really didn't foresee like how AI would revolutionize IT industry. Back then, we were like really learning how to code, how to write clean code, how to follow some conventions, clear project structure, and not to how to like manage agents, write specifications for agents, etc. And well, actually, my opinion now is that this clean code, clear structures, and clear conventions in projects still matter, and might actually matter even more, because imagine that like usually in the project you onboard some new developers once in a while, but with AI you basically onboard all the time. Like every AI agent needs to onboard on a project, and with then onboarding, it's really hard if you have many hacky solutions, many exceptions. You don't know what conventions apply through the whole project. So I think that having clear conventions, clear project structure, and having clean code is what basically makes projects AI ready. And in this talk, I will present a Python template for Databricks talk that sets clear conventions and structure. It's not meant as a silver bullet, as Vojta mentioned. There are different approaches. You will actually see different approach in the second talk. So this is one of the approaches, how to set clear structure and clear conventions. But before we delve into that, actually, let me introduce myself. I'm Jan Lukany. I work as a team lead at Datamole, at team lead of data engineering team, and I've been working there for over 10 years now. And I have experience with Databricks, I think 3 or 4 years hands-on. And in Datamole, we are actually like a software house, but not, I would dare say, not classic software house. We are focusing on agri-tech, biotech, food tech, and other industrial sectors. For example, you can see on the slide a milking robot on a farm, upper left corner. That's a robot where a cow enters on a farm and it's automatically milked by that robot. There is a sprayer with hundreds of sensors on the right there. There is a smart coffee machine which sends a lot of data to cloud. And these are like examples of our customers that for who we build custom AI IoT solutions. But this talk is not about Datamole, it's about Databricks. So let's get to that. First, let me introduce my simplified view on Databricks projects landscape. I would distinguish like 2 types of Databricks projects, and it's a simplified view. The first type communicates with some external systems. For example, some SQL databases, some external blob storages where you have JSONs, CSVs. You import the data or you export the data. And then typically store those data after some transformations to the Unity catalog. You use a CD1, a CD2 to track all the changes. And these are typically the warehouses, some ingestion pipelines, or the exports. But then you have the second type, which typically has both input and output from Unity catalog. This is typically where you build some ML AI projects or build some insights. Let me give an example. The type 2 is what we'll focus on today. Imagine a simple anomaly detection project. So you have some telemetry data from robot, measuring vibration, temperature, humidity, and you want to detect when there's something wrong going on. For example, temperature exceeds some threshold with some white box model, or some ML model running on that, just black box, doing some magic and detecting when there's some anomalous pattern. You can imagine as an input some telemetry from a delta table, and the output would be a delta table with anomalies. Based on that anomalies, you could alert technicians or just generate some dashboards that people can view. So this is an example type 2 project that would fit into the template we are going to discuss. How to build type 2 projects? Well, ideally, you write the specification and let AI build it, right? I think right now, if we would put a specification and run an AI agent on it, it might not perform like ideally. Maybe the third talk today might prove me wrong, or it might make me think that it will perform better. But I think we need some to set some solid foundations and some clear structure for those projects. Actually, what we prefer that in the template is local first development. So really the old school that you develop code locally and you run tests locally. Typically, in Python, just UV run PyTest. We deploy the ABs, whatever the abbreviation currently stands for. We run some integration testing, and we have the template as an open source project. I will talk in the rest of the talk about these three topics: the development, local, deploying, and then the integration testing. So first, local development. How do we approach it? And actually, why do we prefer like local first development? Well, local first development provides quick feedback. So if you develop something, just run UV, run PyTest, you get ideally within seconds a feedback whether it's correct or not. Either you or the AI agent. It's cost efficient. You don't have to have any Databricks compute running. You just run on your computer. All the developers or even the AI agents can run on your computer. And you have available rich tooling, so you can choose your preferred IDE, preferred AI agent. These are reasons why we prefer still local development. How does it look like? Here's a sample code of the anomaly detection, really the skeleton part, where you provide a Spark as a parameter, some source table, target table, and the core domain logic is in the row second from the bottom, the detect anomalies. That basically does the PySpark logic of transforming the telemetry data to the anomalies. And so within this function, we load the table and we write the anomalies table as a delta. That's a simple example of code that can be local first. How do we test it? We actually use PyTest, as I mentioned, and we use two fixtures: a Spark as a local fixture, and seeded mocked data. Here it's called basic tables. Basic meaning some basic scenario. That basic tables basically seeds the tables we need. Then we run the function and compare the resulting data frame with the expected data frame. And this can really run within seconds on your local computer. Yeah, as I mentioned, we need the Spark and some seeded data. And for that, we actually already have battle tested our package, which we've open sourced, PySpark DT. It stands for PySpark Delta Testing. What it does, it provides functionality to create Spark session locally that initiates Hive metastore and enables storing tables as deltas. And it enables defining the C data, for example, like either dynamically or somehow statically. You just define the testing data. Here it's really like not real data, the mock data for testing. And within the fixture, you basically seed all the testing data to the catalog, to the local catalog on your computer. So the PySpark DT provides this. It provides on static data. We are experimenting also with like dynamic loading of the data, and also we are experimenting with a new library called Sail from Lake HQ, because the PySpark, when you run locally, if you've ever run PySpark locally, you might know that it might take like high units of seconds to spin up, or even like 10 seconds to start, which already like does not provide that good quick feedback. Like for example, 20 seconds is still fine, but it can be quite tedious if you do it if you need to do it very quickly or very frequently. And with Sail, which is like a drop-in replacement for Spark written in Rust, we achieve like sub-second tests. So if we run PyTest, it's really sub-second with small data sets. And you don't need to have installed Java for PySpark. So that's what we are experimenting with, but we don't have it battle tested. So if you'd like to test it, I recommend now the PySpark DT. All right, so we have some code developed. We have it unit tested. And basically we use notebooks to run in Databricks, and we use them mostly as a glue code. So imports, loading some configuration, which catalog to write to, which schema to write to, and then running the function. So typically, as it's a glue code, there is like no need to test anything. But there are cases where we might want to develop directly in Databricks and test in Databricks. What could be the reasons? We might use some Databricks proprietary features which we cannot develop and test locally. For example, materialized views, delta life tables, or whatever they are called now, Lakeflow declarative pipelines, I think. So these features we can't test locally. So for that, we need to somehow develop that in Databricks. And also, if we unit test it locally, we do not provide that exact same runtime as in Databricks. So yes, we use the same Python dependencies, or like similar Python dependencies, but we might not use the exact same versions. The Databricks runtime might use different version of Spark, different version of Pandas, Polars. So we don't have the exact same environment. And running in Databricks provides that. So how do we do that? How do we develop in Databricks when we need to? We have a development environment where we isolate, like for each developer, their own schemas or possibly catalogs, tables. And we seed them with the test data. So this is a snippet from the configuration file where we have multiple environments where we specify which catalogs to write to. And you notice the def ID variable. So this def ID variable gets replaced by username of the developer. So in the Unity catalog, it can look like this in dev environment, that you have like multiple catalogs, each prefixed with individual developers. So then we take the mock data, the static data we have for testing, and we load them to these development schemas on dev environment. So when we seed it, we can run the notebooks directly in development environment, verify that the output matches when we modify the notebooks. So that's how we develop within Databricks, if we need to. And there's just one technical note. If we develop interactively in Databricks, the notebooks, we don't have like right now like really clean, simple way how to load all the dependencies and how to develop a library. For example, we typically develop code in src folder, and typically we develop the notebook, but next to that we develop the library because we don't want to put everything in a notebook, but we want to modularize it. And for that, we've developed like bootstrap functionality that installs all the dependencies, includes that source code. If anyone has any like experience with this or any ideas how it can be solved a different way, maybe somehow natively, we are definitely like open. Definitely reach out. We will be interested. And that's only for interactive development of the notebooks. If we run them as jobs, we already like built a wheel of the src and attach it and install it as a wheel in the job cluster. So there, this bootstrap is basically no operation. All right, now let's get to the deployment. So we have everything developed, ideally unit tested in Databricks, and we use the DABs. I think now declarative asset bundles, right? So we build the src as a wheel artifact and install it in job cluster. This is actually adhering to the default Python template from Databricks. So that's not what we like invented. That's what we already took from the default official Python template from Databricks. But what we have like a different way is the YAML config, where we use the dev ID for individual developers when developing in Databricks. So basically, the DAB parameters are just path to that config file, to that YAML file, and which environment it should run, it should take from that config file. All right, so in the like the fully major projects where we want to use all like 4 environments, we use typically we would use like dev environment for only the seeded data. So no real, if we would consume some data from source systems, the dev environment would typically not have access to that. Just really the seeded mock data and isolated using the dev ID. In the TST, we would already test on real data. One of the workflows we have is that we like just deploy to TST on merge to main. And there we already run the pipeline, not on seeded data, but on the actual data. So if we, for example, would consume the telemetry data, we would already consume from like that warehouse that contains the telemetry data. Then the acceptance that already like contains access to the end users, for example, exporting the anomalies, some alerts to some subset of technicians, and then production. These like typically are ad hoc, somehow controlled flows that when the testing succeeds on test, then we proceed to acceptance or production. And so the dev is basically per user or per CI run. I would talk about CI later. And the following 3 environments already use like service accounts. They are not for developers. The pipelines there do not run using developer identities, but they already use service accounts. For example, service principal in Azure. So that's for the environments. And now the last part, integration tests. Just a caveat, we do not have this battle tested yet on like real projects, but we have quite a good, like quite clear idea how we would implement it, and we have tested it just on a like a proof of concept. So when we want to like bring from dev to test, like basically promote between environments. We can, of course, like test locally and then manually in Databricks. But ideally, we want to have some like integration tests that we would run, for example, in CI. And how we imagine them is that we have like a pipeline where this is a Databricks pipeline where we see the data in the catalog. The second step is running the pipeline, so running all the transformation, detecting anomalies. The third step is verifying, so this is the actual testing. The third box is where it would fail if there is some issue, so assert whether data frame equals. And the last part is tear down, so deleting all the schemas, deleting all the tables, schemas. And that's an integration test that every developer can run manually, or it can be run in CI. So basically, when we open a pull request, there would be a CI action that deploys the bundle to the dev environment. It would run the integration test pipeline with variable the dev ID equal to some, for example, CI GitHub Action run ID. Run the pipeline and then tear down, like destroy the bundle. So this way, basically, when we open a pull request, we would run the integration end-to-end testing with fully mock data. We clean, tear down both the bundle and all the data, and we have a result, whether the test was successful or not. So this way, we can, in an isolated manner, test all the changes to in all the branches. So for example, if we do a hotfix on production, we can just develop the hotfix, run the integration test against development environment on that mock data, and then merge the hotfix. So that's how we imagine the integration tests. All right, that was from the main part. So just a quick summary. If you would like to try this template of local unit testing, developing in Databricks with the bootstrap logic, using the deployment with Databricks asset bundles with the configurations, dev ID, isolated environments, and the integration tests, you can check out this repository. It's like initial version, and we will be very pleased with any like feedback, contributions. We'll be really interested in how you do that, or possibly if you want to open pull request, definitely feel free to. We'll be happy. All right, and some further notes. I was presenting this template, but it's like a work of many fellow data molers. So really kudos to mainly my Helen data engineering team, but also to others. And if you are interested in like Databricks, but also Datamole and our other tech stacks, or how we use Databricks in other ways, I recommend a Data Talk podcast from our CTO and data engineering lead. Link here. So that's all from my side, how we approach and envision like Databricks AI ready projects.
All right, thank you, Jan. So we definitely have some time for questions. So if there is anything from the audience that you want to ask now.
Yeah, and if you would have any feedback, please scan this QR code. It's just a very quick survey.
So I would ask one follow-up. So you mentioned, for example, the integration test is something that you need to still like battle test. Is there any further development that you see how this could evolve in the future?
Like I think the further evolution is the testing in like really complex projects. How I think mainly how costly it would be to run all the integration tests either against every change or whether somehow ad hoc. Or for example, I imagine is that it could be when the pull request is not draft anymore, then we can run the integration tests. So that's one thing to consider, like some cost efficiency.
All right. We have one question, so I can borrow my mic.
For anomaly detection, do you have some patterns in a table, or do you learn it from small data, short data?
Yeah, like this was just an example project, but generally speaking, like I think there are two main types of these ML AI projects. One is the white box one, where we really develop the rules for the thresholds for some detection of anomalies, advices, insights. And the second approach is more data-driven black box, where we really take like larger data set, build ML model on it. So the first one is like the expert-driven, rule-based white box, and the second one really the data-driven on typically on large data. Yeah, the expert model are typically like manually defined, so it needs like manual refinement.
All right. We'll have one more question if anyone wants to ask before we have next speaker. So I will just try to repeat the question for the recording. So if I understand it correctly, like so how do you handle like projects that really needs like really big data, like petabytes of data, to actually ensure that the local sample or the local seed is actually representative to what you have in the production?
Mm-hmm. Well, the short answer is that we don't seed that big data. So we typically like use the really small data sets for seeding. So that's actually what we'd be interested in, like how to approach that. So
my next question will be arising of the clusterization of the data. So that means like when you are trying to run multiple jobs, so it has to be like clusterized. The data run has to be clusterized.
you mean like what? If I understand the question correctly. Mm-hmm. So if I understand the question, that if we would want to, yeah, on the big data, if we want to, like we can't do that in memory, so we would wait. That's where the clusterization comes into play. So that's what the local unit testing basically does not cover. That this large scale tests, basic scale testing. Yeah, actually, that I think that's one way how to approach it is to test it on the test environment. That in the test environment you already can have like large data set with real data. So you can have it merged to main. Then you see there is some issue. Of course, then main is broken. But I think since that is still test environment, that is fine. So that's one way how to approach it without needing to like seed large data sets.
All right, so one more time, thank you, Jan, for your talk. And if you're going to stick around for the networking,
yeah, I will.
More questions can follow, and you can meet him later afterwards as well. So thank you again.